Hello everyone and welcome to episode 3 of The Jolly Programmer. Let's get started. Hey! I got slightly distracted and slowed down in the middle because, of course, Windows popped up and went nuts, and it's just popped up again and is still going nuts. Anyway, we are going to have a relatively short stream today because I don't have too much time. And episode 3, I rewatched episodes 1 and 2, and basically I just want to fix some bits. There are certain aspects I wasn't that clear on, specifically null-terminating characters, and we're also going to go over arrays in a bit more depth, and if we have time, we might look at conditional statements. Okay, so we do not open that. That is the wrong window. We open this window. Here I have written a very simple... I have wrote a very simple program. Yes, now this should look pretty familiar from last time. We still have the hash include iostream, the using namespace, and we also have an array of type char. Okay, so all we are doing here is creating an array. We are naming it array1. It can contain 5 characters, and I'm setting those 5 characters here. Now, we have array 2 down here. We're only setting it to 4 characters, but technically it's 5, because remember, if you declare a string like this, you get the null-terminating character, and this program is to demonstrate what that does. So, let's try outputting array number 2. Okay, I'm just going to build a solution. So, we should see 0, 1, 2, 3 in console. And indeed, 0, 1, 2, 3, there we go. But if we change this to array 1, we should see, you might think, 0, 1, 2, 3, 4, because all this does is it puts 0 in element 0 of the array, 1 in element 1, etc. Just to clarify, I could type whatever I want there. This is still going to go in element 0 or index 0. This will be index 1, etc. You always count from 0. Oh, and he writes a 1. Anyway, I'll just build that. So now we're going to have a look at the first array. And we'd expect 0, 1, 2, 3, 4. Oh! But what do we have? We have 0, 1, 2, 3, 4, loads of gobbledygook and loads of other stuff, and a quarter and a heart symbol, I believe, is in there, and a capital E. So, what's going on here? Alright, first of all, this string, this character array, isn't technically a string. It doesn't have a null-terminating character at the end of it. A null-terminating character is what tells the program it's got to the end of the string, and it's just used by a lot of functions, for example, cout to tell it when to stop outputting. So what this actually is, if I had to show you what this means up here, it would look like this. I think that's right. I sometimes get it wrong. Let's just check. Now we're going to output array 1 and see what we get. 0, 1, 2, 3. Excellent. So what is going on is this is our null-terminating character. Basically, there's a difference between double quotes, like this, and single quotes. Single quotes means you are defining one character, okay? But this means you are automatically appending the null-terminating character onto the end, so you just need to be aware of that in array sizes. So this may say array 2, and it's 5 big, and while it is 5 big, because this is what it looks like, 0, 1, 2, 3, and the null-terminating character, it only looks like 4, so many people would think you can do this, but if you try and build that, you'll get an error array bounds overflow, and that can lead to some nasty bugs. So, hopefully that's cleared this up, basically. And while we're on the subject of arrays, we're just going to have a look, because arrays are kind of useful. Let's say we want to store a list of names in a program. Okay, we need to first get rid of all that, and we'll just say char array1. You can call, actually no, list, can't ever type when I do these, list of names. Now, I'm going to point something out. I don't know if you've noticed, but when I write like more words in a row, I use capital letters at the start of each word. That is called Camelcase Notation, and you don't have to do it, it's not required, but a lot of people think it makes it easier to read because you can't have spaces in a variable name. That would be an error. So anyway, we want names. Let me think. Let's introduce a new concept. Let's say we want to be able to store 10 names. Well, if we wanted to store 10 characters, we would just do this. So if we want to store 10 names, really, we need a list of 10, but each one of those in itself is a list. So what we can do is this. Now, this is a two-dimensional array. It's two-dimensional because it would, if you drew this, it would be kind of a 2 by 2, not 2 by 2. You've got two axes. You've got your x, which is what the 10 is, and you've got your y, which is what the 64. Though you could do it backwards if you wanted, but you'd be a bit crazy. Although I'm going to make this a much smaller, just for demonstration purposes. Let's just have that. That should do. Okay, so the first one. It's actually a while since I've declared something like this. Let's have Jim. Okay. Let's have Ted. I could be doing this completely wrong, so bear with me, don't copy it down yet. And then let's have Master Chief. And I intentionally did that because it's going to give me an error. Notice if you make a mistake, sometimes the compiler will warn you. Like here, you'd need a 13, so let's go 14 just to be safe. Error goes away. Let's build a program, build solution. Array1 undeclared identifier. That is because I changed the name. Let's just chuck that in there. And start without debugging. Now, this is me being stupid, but what we have here, this is actually the address in memory. It's a hexadecimal value of the first point. Okay, so that is the address of the first bit. Now, this is kind of important in some way because I can explain a little thing to you. You may have heard that you get 32-bit computers and 64-bit computers. Well, the primary difference is in a 32-bit computer, this address is 4 bytes long. So we see 00, that's 1 byte, 1F, that's another byte, FC is the third byte, and 84 is the fourth byte. So you can, whatever number you can represent with 4 bytes, that's how high in memory you can go. Now, if we take a calculator, I really hate this calculator. What is it going to be? It's going to be 2 to the power of... Okay, well, let's do for a single byte first. So 2 to the power of 8 should be 256. Okay, now 32-bit, so 2 to the power of 32. What am I doing? I click square root. 2 to the power of 32 is this number. Big number. Woo! It's actually more than I thought it would be. So, overall, on a 32-bit system, it's impossible for the computer to access more than 4 gigs of RAM, and I'm pretty sure for a specific application it's limited to 2 gigs. I'm not sure why, I can't remember, there is a reason. But with a 64-bit operating system, you see we get a much bigger number, 2 to the power of 64. Yeah, that's how much memory we can access, and for now that might as well be considered infinite. It's not an issue. So that's why 64-bit operating systems generally are coming in now, because programs are using more memory. I realise this is kind of a bit of a sidetrack, but that just explains what this address actually is. It's 4 bytes, which is 32 bits. There are always 8 bits in a byte. In the modern world, in the past it was slightly different sometimes, but generally that is the case. So anyway, we've got our list. Let's say we want to output Jim. All we have to do, 0. Build. Start without debugging. And we get Jim. So what if we want to output all of them? Well, there is an easy way. We could simply copy and paste this and change the numbers. Start without debugging. Jim, Ted, Master Chief. Excellent. So that is a nice way of storing information. And often, say... The best example I can think of this, actually, and I might program this in a further episode in this series, is noughts and crosses. Imagine you're playing noughts and crosses. What do you need? You need a 3x3 grid. Doesn't that just scream 3x3 array? And I mean, it would be inefficient, but if you really wanted to, you could actually write empty, naught, or cross in each square. You could actually do it like that. And we might, because that would be good, because I could go over string comparisons. So anyway, we've covered the arrays a little bit, but you don't just have arrays of type char. You can also have all right, these are the common ones. Int bool, we'll have double float. Okay, you can Google what each of these does, but char is 1 byte. It's just a character, so a list of characters. Int is a number. It's a reasonably big number. In fact, I think it's a 32-bit. I could be wrong. 4 bytes. Bool is just true or false. And so they just have different purposes. Trying to think of a good example. can't at the moment. But anyway, we'll get into that later. So I've cleared up the arrays, I've demonstrated the null-terminating character, and actually I should be able to do this. Let me just show you. See if you can do this. I'm not actually sure if you can. Let's see, can we do that? Apparently we can. We still get Ted, but remember, if we make this 14 long and we forget the null-terminating character, it will go into infinity, basically. I think it automatically appends a null-terminating character if you don't fill up all of them. I'm pretty sure it does. Anyway, hopefully this has been useful for you guys, and I'm not going to do if statements today. I've decided that can be another day, but I was just clearing up arrays. Though, saying that, I would like you, if you can, to get rid of this. Do something along the lines of this. It doesn't have to be exact. That'll be all white space, actually, won't it? I want you to try and make the noughts and crosses board. I don't want you to have any logic or programming in it. I just want you to make the program draw a board. So you saw me draw a list of names. I want you to see if you can draw a board. And if you can, we might do that next week. Otherwise, we'll find something else. Thank you for watching, guys, and remember, please, if you want, recommend tunes. I've got millions in there somewhere. Don't know. Whatever, or I can learn some one. Anyway, thanks for watching, guys.